This is problem 3, section 3.7. At what values of x on the curve does the tangent line have the largest slope? Okay. If there are more values of x, separate them by commas, right? So the curve is given by y equals 3 plus 250 x cubed minus 3x to the power 5. You want tangent line on this curve to have the largest slope, okay, highest slope. So let's see how we address this. So this is the curve y equals 3 plus 250x cubed minus 3x to the 5th. We want larger slope. That is, we want to maximize the derivative of this function, okay. Let f denote the derivative function. That is, we want to maximize f. So what is the derivative here? Well, this gives me 0. This gives me 3 times 250 x to the power 2 minus 5 times 3 x to the power 4. All right. So that gives me 3 times 250 is 750. 3 times 5 is 15. Power is the same, x squared x to the 4. Okay. So this is my function. I wish to maximize it. Okay. So notice, let there be no confusion. We want larger slope. That is, the derivative function of this expression must be maximized. So fx is the function that we wish to maximize. Now this is a polynomial function, so it's defined for all values of x. Therefore, the domain of f is negative infinity to positive infinity. We want to maximize this function, so let's start by looking for its critical numbers. How do you find critical numbers of any function? You take its derivative. In particular, this function's derivative. 750, 2 comes down, x minus 15, 4 comes down, x cubed. Simplifying, 750 times 2, 1500, x minus 15 times 4, 60, x cubed. I'm going to solve for f prime equals 0. So let's factor this. If you notice, 60x is common, is a common factor. 60 times 25 is 1500. Okay, you can check. So 25 inside minus, well, I got 60 and an x out. So what's left? X to the power 2 is left. So derivative is defined everywhere. So the only way of finding critical numbers is by setting the derivative to 0. So write this expression to 0. So when something is 0, well, factors are 0. 60x is 0, or 25 minus x squared is 0. 60x is 0, so divide both sides by 60, you get x equals 0. Or here, well, this means x squared, if I move the x squared to the other side, x squared is 25. X is 0, and from here, taking square roots, you get 5 or negative 5. These are my critical numbers. So negative 5 is the smallest, 0 is in the middle, positive 5 is on the right hand side. Now use the intervals negative infinity to negative 5, negative 5 to 0, 0 to 5, and 5 to infinity. Okay. Choose any number from each of these intervals. I choose negative 6 here. You could have chosen negative 10, whatever, negative 100. Choose any number between negative 5 and 0. Negative 1, 0 to 5, 1, 5 to infinity, 6. So choose test points from each of these intervals. Now plug in these values in your f prime. Okay. F prime is this expression. Okay. Plugging in negative. Okay. 60 times negative. I don't care for the value. It gives me a negative. Now what about this? 25 minus negative 6 squared. So you see, that's a positive 36. So 25 minus positive 36 will give me a negative. So in all, it's a positive. Likewise, when I plug in negative 1, I get a negative from here, and negative 1 squared makes a positive, but 25 minus 1 is a positive. So overall a negative. Likewise, plug in x equals 1, you get a positive and a positive. Lastly, x equals 6, a positive and a negative. 6 squared is negative is 36. So 25 minus 36, that's a negative, overall negative. So what do we have on these intervals? I'm increasing here because it's positive derivative, decreasing in the second piece, increasing here and decreasing there. So now you want to maximize your function. So you need to look at the maximum of negative 5 and f of 5. Why only these two? Why not 0? Let's figure out. So you see, I'm increasing here. So whatever I'm doing, I'm going to be increasing here. And then I'm decreasing. So I'm decreasing here. After 0, I'm increasing again. And after 5, I'm decreasing again. Okay. See, I don't know whether this is my picture. But the point is, maximum I will get from this and this, not from this, because this is anyway lower than the either sides. Okay. So I'll plug in negative 5 and 5 into my original function f, which is what I want to maximize. I plug it in and I plug it in. I should get equal, it seems. Well, do I? Look at that. These are even power. Square, negative 5 squared is positive 25. Positive 5 squared is positive 25. Here, x to the power 4, negative 5 power 4 will be positive 625. 5 to the power 4 will be positive 625. So everything else being the same, these fetch me the same values. I don't care what the values are, but I know that the maximum will occur at these two numbers, negative 5 and 5. Okay. Oops, got kicked out. Okay. So this answer is correct. I'll stop my video here.